Descriptive statistics. As part of this class, you will go through a series of 5 Excel modules. The goal of these modules is to give you a brief introduction to Excel and to basic statistics. You are likely to take a statistics class like environmetrics or biostats during your time at Juniata. In this module, I will go over descriptive statistics. Descriptive statistics is a quantitative summary of the data that you collect. We're looking for patterns that might emerge from the data. So let's start with population. A population is a total number of individuals of the same organism living in a defined geographic area. In statistics, a population is a complete set of items that shares at least one property in common. An example would be the population of white-tailed deer in northeastern US. I will use the deer example to illustrate the rest of the terms. A sample or a statistical sample is a subset of measures selected from the population. An example of a sample would be deer harvested on the first day of rifle season. A variable is a characteristic that can be measured or counted. Variables can change over time. An example would be the weight of deer harvested on the first day. An experimental unit is what you apply variables to, then observe and collect data on. So the deer in this example would be the experimental unit. Finally, an observation is when you collect data on the experimental unit, thus forming your data set. Now I'd like to move on to central tendency, which is the central or typical value of your observation. So your first central tendency is the mean. Mean is also referred to as average or the arithmetic average. The mean is generated by the sum of all values collected in your sample divided by the number of observations. Using the deer example, let's say we weighed 5 deer in kilograms. So here you have a 45, 61, 42, 58, and 61. These are the deer weights, and you divide it by the number of observations, which is 5. So your mean in this case would be 53.4 kilograms. Next, the range. The range is the difference in observations, difference between the largest and the smallest observations. So using the values from above, it ranges from 61 to 42. So 61 minus 42 equals 19. The range can also be useful when there are small variations between observed values. Median is the middle value. In an ordered data set, the median is the middle value. So if the deer weights were organized from the smallest to the largest, you have 40, 42, 45, 58, 61, and 61. Your middle value is 58, which is your median. Remember, this formula works well for data sets with an odd number of measurements. So if you have an even number of measurements, you won't get a whole number for the value. In this case, you take the middle two numbers and average them to get the median. The mode is the measurement that occurs the most often in a data set. In this case, the mode is 61, right? Because you have two 61s and everything else has a single value. If a data set has two modes, the term used to describe that data set is bimodal. Now let's look at a data set to understand these terms. Here you have a list of colleges with average SAT and ACT scores for incoming freshmen. The population are colleges in the US. The sample are these specific colleges. The SAT scores are the variables measured. To determine the range of each subject, you need to make sure that you are on the top left cell of the sheet. In this case, it's college name. Then select Home, Sort and Filter, and Custom Sort. Now you can see this pop-up menu, and then you choose what you want to sort by. Let's select Math SAT scores, okay? Order it from the smallest to largest. Click OK. Now the Math SAT scores are organized from the smallest SAT score at the top and go right to the bottom of that row, and you will see that the largest SAT score is at the bottom. Now let's determine the average score for Math SATs from this sample of incoming freshmen. First, select the cell you want the mean to be in. So here's where the mean will go. Then go to the Formulas tab at the top, insert function, and then average. If you don't see it, type in the word average and hit OK. Then, in number 1, you want to select the numbers you want averaged. Select the numbers and click OK. Now you can see that the mean Math SAT score is 511.25. Now, please calculate the mean for the verbal SAT scores. All right, now we're going to use Excel to determine the median. Again, we will select the cell that we want the median to go into. Then we go to Formula, insert function, and then you select median. Again, if you don't see median, you can type median and then click Go. Like before, we're going to select the data we want to find the median of and then click OK. So again, we are going to get the median for the Math SAT scores. Go all the way to the end and click OK. You can see that the median Math SAT score is 500.5. Now calculate the median SAT score for the verbal scores. For homework, go to the second sheet tab at the bottom. Here you have the raw data for sapling heights. Please provide a mean, range, mode, and median for this data. Save your answer sheet and upload to Moodle.